Good morning, everyone. So my name is Ulysse Couvrat, and today I'm going to present you the project I worked on. So it's optical properties of wet ink for security card and identity documents. So sadly, my comrade cannot come today because he's sick. So first, I want to thank Mathieu Hébert, Nicolas Dallos, and Manuel Flores for the help on the project. So first, I'm going to talk about the context, then the methods we used to identify how white ink work, then the result that we got, and I'm going to conclude on the white ink. So first, nowadays, counterfeit identity documents are rising a lot, and it's a problem for a lot of industry worldwide. 70% of industry that fabricate identity documents say that counterfeit documents are a problem. And nowadays, 3 out of 10 documents are fake, and they are sold 8 times of 10 online. So to counter those counterfeit documents, white ink is maybe a good solution. I'm going to explain why. So to identify the properties of white ink, we used 3 different type of card. Normal card, like just with white normal ink card, and white ink with a special layer between 2 slices of polycarbonate, and the last one is a half-tone card, where we put 0% of white ink, 25, 50, 75, and 100% of white card, and with a strip pattern. So here is the method that we used with my partner in order to identify the properties of those different cards. With a spectrophotometer from X-Rite, we measure the reflectance factor and the transmittance factor. Then we use the Kumbelka-Munck model that we have modelized on Python. Then with the Kumbelka-Munck model, we plot the scattering factors and the absorption factors, and we see how it changes depending on the card. Also, we have plotted the colorimetric gap of the different cards to see how the eyes of a human can see the different perception of the colors. So to talk a little bit about the Kumbelka-Munck model, this model is for materials that are passing through only a material without hair in the middle. So we have a lot of factors here that are important. So like, for example, the light that are reflected on the light that are transmitted, that pass through the material. So sadly, I don't know a lot about this part because that was my partner that was about to talk about this. But yeah, there is limit about this model that the material need to be isotrope and need to diffuse the light, and it's never going to be a material that has a total reflection because, well, it's light not going to pass through if it's total reflection. So also to calculate the colorimetric gap, we use the model CELIB from 1976. So it's the colorimetric distance in 3D. So to calculate the colorimetric distance, we divide the reflectance with the transmittance, and we add the illuminate. So the illuminance that we use is the D75, and with this we can calculate delta E. So to see the results, so those are the absorption coefficient and the scattering coefficient. We can see for just white card, normal white card, coefficients are all the same. And they all for absorption are around 18%, and for the scattering 2%. So there is more absorption than scattering. Here we can see the result of colorimetric distance, where, well, there's a lot of number, but the more important are the means and the standard deviation, where you can see that for here white card, it never exceed 1%. Here also, and here it's exceed for white ink, a little bit of, for 3%. For the painting card, so painting card is white ink. The special ink that we use, we want to use for document, for identity documents, we can see that absorption is the same always, but scattering here is changing because of the size of the layer of white ink in between the polycarbonate slice in the card. And one of the most interesting one is for the half-tone card. We can see that absorption is still the same one, but the scattering coefficient change depending on the half-tone of the card with the strip pattern. We can use this in a identity document to identify if there are false or true documents, because by changing the half-tone, so the percentage of white ink in cards, by changing the shape, because if it's transparent, the transmittance will not be the same number. And by adding this with already existing security methods like UV ink, we can create a new way to fight counterfeit documents. And white ink is a good solution to this. It's already used in a lot of countries like US and Canada, Germany also. And that's pretty much all. Thank you.